The core objectives of the core objectives of air conditioning systems are healthy, productive, comfortable indoor environment, heating to. Can you hear me also?
Sir.
Okay.
Sir.
I'm reading the lecture. Can you hear me now?
Yes, sir. We can hear.
Okay.
Yes, sir.
If some problem appears, please speak in between. Now, core objectives of my lecture, this today's lecture are air conditioning overview, and the air conditioning systems objectives are healthy, productive, comfortable indoor environment. To create healthy, productive, comfortable indoor environment, heating to perimeter spaces are the topic. Cooling to perimeter and core spaces, humidification and dehumidification is needed, ventilation to occupied spaces, deliver over time and space. So these are the core objectives. I'll explain every item separately now. Heating to perimeter spaces. This is what is perimeter spaces. Just imagine a huge building like a hotel, multi-story building, flats, hotels, things like that, and perimeter means external wall के साथ जो attached rooms हैं, they are called as perimeter. They are exposed to external wall. So heating to perimeter spaces. In winter, you may need to heat. In winter, you may need to heat the perimeter spaces. And inside the deep inside rooms, inside the building, away from the external wall, may require heating. So in winter and summer, both temperature maintenance is required. Similarly, in summer, perimeter spaces may need cooling, and inside spaces may also need cooling, because heat inside the perimeter, deep inside the building, the rooms are not directly exposed to external wall. So in winter they do not lose their heat. That's why they are kept warm, and you don't need to heat them. So sometimes they are so hot that you need even cooling during winter inside the core. This is the purpose of heating to perimeter spaces and cooling to the perimeter and core spaces. So humidification or dehumidification is needed. Sometimes humidification is required in winter and dehumidification is required in summer and wet weather. Now, ventilation to occupied spaces. All spaces which are occupied for air conditioning, if they are occupied, human being is living there or some animals are living there, they need oxygen. For fresh oxygen, they need fresh outdoor air. Maybe winter, maybe summer. In summer, hot air to be brought in and cooled to the room temperature. In winter, cold air to be brought in and heated to the room temperature. So this is the purpose of ventilation to the occupied spaces. If occupied spaces are not ventilated, then this will happen when the world is facing coronavirus and disease. So this is the purpose of air conditioning, to provide fresh air, outside air, to avoid any control time and space. So the all space, the air conditioning system will cover all space which is required to be heated and cooled, and during the time when it is required to heat and cool. Now, time and space. This needs. Everybody hearing me?
Yes, sir.
Okay. HVAC needs in each room same over day and over year. You see, when you open the room, just like if I go to my office and early in the morning I open the room and it is winter time, I may need heating. And I may need heating till I sit there from 9 a.m. up to 4 p.m. So this is the purpose of time and space. Which space is occupied during what time? During that time it should be heated and cooled. At any time, may need heating and cooling in different rooms of the building. Or maybe they are not occupied, they are vacant, they are empty. So those may not need heating or cooling. So at any time may need heating and cooling in different rooms of the building. Core needs cooling even in winter. What is core? Any internal rooms? Internal rooms are called core rooms. So internal rooms of the building which are away from the external wall inside the building. Don't imagine our college building. Our college building is open from both sides, so we don't have any core room over there. Imagine about some PC hotel or some some multi-story flats system, 16-story building and several huge building like in New York and any other building. So inside building, away from the outer wall, they are called port space, port rooms. So HVAC system must be simultaneous and bus loads. So simultaneously, HVAC system must meet diverse load. Somewhere cooling, somewhere heating, somewhere nothing to be required. This is the meaning of this sentence. Now, you have following system option. What type of system you can design? If you are asked to design HVAC system for a building, there are two. Separate HVAC system for every zone or one HVAC system for entire building. So now, please don't speak. Now, separate HVAC system for every zone. We may have residential buildings, we may have motels, hotels, we may have strip malls, big malls. So on the roadside. So according to that, we have to design separate HVAC system per zone within residential building, flat system. So we may distribute in the zone. Maybe it is a hospital when one patient may be warmer temperature, higher temperature during summer. Other they need cooler temperature. So young people need cooler temperature. Old sick people need higher temperatures, warmer temperatures. They feel cold and low temperature, so they don't need cooling. So much cooling. So you have to mention each room, each space occupied by who and what temperature he or she may require. So similarly, in commercial building, you don't need too much cooling. In summer, enough cooling so that people will feel not get perspirated and they may do shopping easily. Now, other system is entire building, one zone. So when we have to maintain different temperature in different parts of the building, that is called as multi-zone system. When we design the HVAC system such that we provide same temperature air to every room, anywhere, any floor, any room, then this is called a single zone system. Now, distributed heating, just we discussed in previous lecture. So external noise, please stop external noises.
अब क्या हो गया? सर का माइक ऑफ हो गया। कोई पर्सनल एसएमएस ना करो।
सर खामोश क्यों हो गए हैं?
कोई कोड नहीं। अच्छा मेरे ख्याल आवे तो जांच कराओ।
ये काम है, चुप कर यार तुम।
Now, hello. Is my voice muted? Is it okay now? No, can you hear me now? Don't slide on in chat. Can you hear me? Now, distributed HVAC system packaged terminal air conditioner PTAC. I've told you, I've shown the picture in previous lecture. Water to be pumped, that is chilled water system. I've shown you the pictures. Now, packaged rooftop unit RTU, I've shown to you our picture in my previous lecture. Zone 2 and zone 1. Now, system characteristics RTU rooftop unit, which we have seen in previous lecture, zone 2 and zone 1. There will be two types of system rooftop units. These are called as terminal units. Distributed units are unitary systems. So rooftop units are split system. One unit in per each row. You have to specify one according to temperature control, according to heat. You can select a system, a split system, or rooftop unit RTU and install it locally in a particular zone. So refrigerant and cooling coil. Now you have to take care of refrigerant flow in each cooling coil if it is distributed refrigerant system. Now ventilation system. Ventilation means outdoor air, fresh air with fresh oxygen. So indoor dirty polluted air must be exhausted from the occupied space, and fresh equal amount outdoor air must be reduced. But before introducing that outdoor fresh air, its temperature must be controlled. Temperature and humidity must be controlled. It must be cooled or heated. It must be humidified and dehumidified before sending to the air conditioned zone. Now, sealing diffusers and ductworks are required to distribute air in different zones and different rooms and within the room in different corners and different places over and near the occupants. Now, simple controls, one thermostat for one zone is enough. So thermostat allows user, the occupant, to control what temperature he needs to be set in the room. Now, separate billing for each tenant is possible because of this system that which I am describing now. That is multizone system and rooftop unit and split system. In this case, separate billing for each tenant can be done because its unit will be connected with electric meter and that meter will be billed to him. But central AC system, not unitary system, which is centralized huge air conditioning system, that is only one meter and one system. So you cannot say that this is your bill. So sometimes separate boiler and radiators are required for this unitary system. What is zoning? Now I'll explain the zoning. One thermostat per zone is required. So thermostat means you set a time, temperature required, and when that temperature is set, AC system is shut off automatically. When that temperature is exceeded, AC system is put on automatically, and in this way, temperature is controlled. Now, rooms with similar load profiles. You connect zones of the room with similar load profile. What type of load should be, if type of load is similar, so you can combine them and make one zone. So, for example, the good example is offices on same side of the building. Which really from load depends on the side of the building also. Some exposed to west, some side exposed to east, some side exposed to north and south. So accordingly, the load differs. So one side of the this is a good example to collect them and make one zone. Now, bad example is exterior opposite interior. Exterior interior should not be made in one zone because exterior rooms, the perimeter rooms, have different load configuration. They change differently, and interior or core offices change differently. But somebody is saying, so kindly teach in native language because sound isn't clear. Why sound isn't clear? Native language में कुछ भी होता है, sound तो clear नहीं आएगी. तो sound clear नहीं है तो मेरा system तो मेरे ख्याल में काफी मैंने recording देखी है, sound system clear आ रहा है. अब आप अपना check कर लें, आपके कंप्यूटर में वॉल्यूम वगैरह check करें. Yes, you are right. Birds may be chirping because in the neighborhood, in the corridor, in the other room, in the terrace, my birds are shouting. Maybe some bhaji wala, sabji wala, aloo wala, chori wala bhi aake shor machayega. That may be disturbing also. I am living in a populated area, and my house is very small, 120 square yard. I am on the first floor, and I have shut all the doors. Nonetheless, external noise may be coming. So I am sorry for that. Now, let's go to the topic. Proximity, one thermostat, and it should be near. Thermostat should be installed near the nearest place which is to be cooled and heated. So air communication allows larger zones. So larger zoning is possible on the basis of air. How easily air can be communicated, how ductwork can be reached there. Now, recognize this. We may see, for example, in the auditorium, it's a huge auditorium, there is a stage. On the stage are many lights, very powerful lights to show the performance. And for audience, lights are not required, too much lights are not required. Some audience may be sitting in back seat and air may not be reaching there. So designer must take care of remote people sitting in a huge auditorium and on the stage, artists performing and under huge lighting, very powerful lighting, and the heat is falling on their, radiated on their faces and they're perspirated. For them, we need special care, special ventilation system, special air flow system, and special temperatures. Now, central AC system, there we use terminal devices like fan coil unit, air handling unit, heat exchanger, central heating and cooling. We will discuss central heating, cooling sources. What are the sources? Sources may be outside air. Outside air takes away heat of cooling tower. In cooling tower takes away heat with the water from evaporator, from chiller. And refrigerants take heat from water to cool water to create chilled water. And chilled air taken from the occupants, takes heat from the occupants and gives to the evaporator. So these circuits are shown. So cooling tower circuit and condenser circuit, compressor and chilled water, evaporator and everything. So in this picture. So now central heating cooling system, we use chiller plant, we use cooling tower, we use boilers, and we use air handling units, and we have other fan coil units. They are called terminal units. Now, what are the benefits of central and distributed system? Central system on left hand side, distributed system on the right hand side is shown. So I have to make distance in the mic. Is it so noisy? If it is so noisy, please control your volume. I can also control my volume. Somebody has just complained that we cannot hear. So it is because of volume of your own system. Here, if it's okay, then I'll continue. Okay. So let's go ahead. Benefits of central and distributed system are mentioned here. On the left hand side is central, benefits of central system, and on the right hand side distributed system. Again, some message. No, please don't ask me native language. I cannot speak Punjabi, I cannot speak Pashto. During my lecture, I cannot speak Urdu because official language of communication, language of study, officially it is English. CH rules, EC rules, medium of instruction in Pakistan in higher education is English only, engineering particularly. Now forget about Urdu. You may go after graduation to some office where foreigners are working, they can speak only English, not any other language. You may just go to Western countries for higher education and lecturer will be American, he will be speaking typical American English, like this. Large equipment have high quality appearance in durability, maintenance concentrated noise removed from zone, the area allows low installed capacity, value from solid, easy to provide zone. So very fast speed and very special accent. So you have to acquire listening power. listening and understanding the comprehensive power of English. That is why TOEFL is necessary for Americans and IELTS is necessary for Britishers. So you have to pass these examinations, only then you are allowed to get admission. So that is why advanced equipment has higher quality, efficiency, and durability. Maintenance is concentrated, noise is removed from the zone, and diversity allows lower installed capacity, can use thermal storage. So these are the advantages of central air conditioning system. Now, what about distributed system, that is split system and package system, things like a window AC system? So they are easy to provide zoning, direct control by occupants, easier independent scheduling for energy saving, generally lower capital cost. This is very important. Capital cost is low and shorter lead time for equipment. So easily you can buy, go to the market, electronics market, and buy easily when you want split system AC, window AC or something like that. So for central AC system, you need a lot of time and you need a lot of money to invest. But their life is very, this point is important. Their life is very high. Central AC system life is 30 years. Economical life, 30 years will work without any problem. But utility cost per month, per month cost will be lower, but initial cost will be very, very high. So in millions of rupees. But our AC, split AC system distribution is very cheap, easily available. You don't need to import, and locally you don't need a contractor, you don't need a supplier, you don't need shipment from foreign country. So lead time is very small. Anytime you go and install, within 1 day that equipment. This is one, but their life is not more than 7 years. Commercial economic life not more than 7 years. On the other hand, central system very expensive, so but it works for 30 years. Now lead time for commercial purposes, downtime is very important. If some institution is running business of billions of rupees per day, and for 2 days its AC is not working, so that owner will be losing billions of rupees in 2 days. That's why downtime is important. Central AC system downtime is very continuous. Now, don't need dedicated. Now, this distribution don't need dedicated maintenance staff, use service contract. The operator can use, owner can operate it, shut it off, clean it, and remove, repair it. Daily repairing and staff maintenance can be done by anybody, non-technical person. But central AC system needs engineers, assistant engineers, technicians, diploma engineers, especially trained in maintenance and operation of that system. Now, can on this right hand side can often install on roof less usable space for equipment. So this is advantage and disadvantage. Also advantage in the sense that it's a small building, single story, 2-story building, you can install on the rooftop. So usable space and within the room you can save your space. But on the other hand, central AC system is installed far away, can be installed far away from the building. Special installation, special building, separately machine room. So next we go to the next topic, next slide. Typical design approach. So what is the design approach for AC system? First of all, it's term. It may be a room, it may be hall, it may be collection of rooms, it may be 5, 10, 20 rooms in one side of the building, huge building. So start that zone. Each room, know how to find load calculation. Cooling heating load calculation you will learn later on when you will study chapter 4. The load calculations are taught. So first calculate loads, then air diffuser zoning terminals, air distributed system, duct design. Also you will learn chapter 6, air handlers, chilled water distribution system, central cooling and heat. So chilled water piping design. This you will learn chapter 7. So these things are required. This is the how to start your AC design. Load calculation. In the zone distribution of diffuser, where people will say where diffuser required, but not required, and on the drawing you have to mention it. Then air distribution system, duct work, how will line diagram of the ducts, where duct will supply, duct will start, where it will end, and return air from where it will start, where it will end. Now air handlers, where will be installed in corridor and room, on rooftop, or outside on the lawn. So this you have to decide. Now central cooling and heat rejection, how to reject the heat, whether condenser will be air cooled or it will be water cooled. You will need cooling tower or you will need just air cooled with fans. Now air handling system, two types: constant air volume system, CAV system, and variable air volume system, VLA system. In previous lecture I have already mentioned it, and this detail you will learn later chapters, chapter 6, when duct system design, air conditioning system design, and psychrometry will be covered. Now, constant zone airflow, has different requirement, different constant air flow, and then with very slow, different quantities of supply air, but temperature remains the same, and volume flow rate remains the same. Now, variable volume system, constant zone supply air temperatures meet varying loads with varying supply air flow. So, air flow may be different in different rooms, different zones. Air temperature may be different in different zones in daily system. Now, there are two types of system that design dual duct system and multi-zone system. In dual duct system, you have separate supply of cold air in one duct and separate supply of hot air in different duct. In cold air, you have cooling, refrigeration plant, stock, evaporator, and heating duct, heating coil will be provided, and it will be heated with hot air or steam. And let us see. Checking. 3 minutes remaining to finish the lecture. So, yes, I know there is a time constraint. I will know 3 minutes remaining. I did not receive a notice. First lecture, you were lucky. I got the message that we were very generous to you with your lecture time. So that's why I was wondering why lecture is not finished in 40 minutes, 30 minutes. So they gave me 1 hour. Now, dual duct system, we mix hot and cold air at each zone. Hot air is separately supplied up to the room, cold air separately up to the room. Near the room, just before the room, there is a mixing box controlled by automatic dampers. Damper has the control unit. Now, late planning is coming. Please stop late planning. Now, come in the time well before the time. Noted time. Noted time is 11:15. You must be 11 o'clock planning. Now, this I'm repeating again. Now, multi-zone system mix hot and cold air for each zone at the air handling. Multi-zone system with you mix hot and cold air at the air handling. So, right at the air handling. Now, not in the other room. Air water system. We use combination of conditioned air and zone water coils. So, air water system means chill water is circulated through the terminal unit, through the fan coil unit, and from the room fan coil unit inside the zone, inside the conditioned zone, and zone or room or space, air is circulated through that coil because of which came through the ceiling or right in the room, above the overhead or in the wall somewhere in the room. So that air circulated over the chill water coil and we get cooling. Now ventilation requires air, outside air. So that air is to be treated separately, cooled separately, or mixed with hot and cold air. The outside air will be hot in summer, inside air will be cold. So they are mixed. So in room temperature will be this up. So we don't mix directly outside air. We just precondition it. Separate air, outdoor air unit is installed sometimes. That is called as dedicated outdoor air handling unit. So outdoor air handling unit in large building, a dedicated unit is required. So that dedicated unit will cool the air. So we will continue lecture till. So what time we started? 11:50. Yes, time is over. Somebody is warning me. So now we will stop here. So please remember, air water system. We stop. So we will continue. This is a lengthy lecture. So general system of classification. We will go to next. Inshallah, we'll cover the next lecture. That will be tomorrow 9:30. So till that, what is